Cartography, the art and science of making maps, is a field that integrates geography, data visualization, and spatial analysis to create tools for navigation, exploration, and understanding of the world. From ancient hand-drawn maps to modern digital geographic information systems, GIS, cartography has evolved significantly, leveraging advancements in technology to produce increasingly accurate and detailed representations of the Earth's surface. Maps play a crucial role in various applications, including urban planning, environmental management, disaster response, and everyday navigation. Our analytic approach to cartography involves examining the relationships between different cartographic elements through the lens of affirmed positive and negated negative triads. This method allows us to explore how these elements influence each other, identifying patterns and interactions that enhance or hinder the effectiveness of maps. By applying this structured framework, we aim to understand and improve the quality and utility of cartographic products, ensuring that they meet the needs of users and accurately represent geographic data. In cartography, coexistence refers to the harmonious relationship between geographic features, map symbols, and user interpretation. For instance, accurate depiction of a river, geographic feature, with a blue line, map symbol, must be easily understood by users as a river. This ensures that all three elements, features, symbols, and interpretation, are aligned, facilitating effective map reading. Conversely, equilibrium highlights the importance of avoiding the absence of these elements, leading to map clutter and user confusion. For example, removing unnecessary details from a map, like excessive minor roads, reduces visual clutter and prevents user confusion, ensuring that the absence of unimportant features does not detract from the map's clarity. Reinforcement in cartography can be seen in the cycle where accurate data collection enhances the reliability of maps, thereby increasing user trust and encouraging more contributions of accurate data. For example, when a community mapping project yields reliable maps, users trust these maps and are more likely to contribute further data, reinforcing the cycle of accuracy and trust. On the other hand, feedback in a negative context occurs when inaccurate symbols lead to data errors, diminishing user trust and perpetuating further inaccuracies. For instance, if a map incorrectly marks a school as a hospital, users may distrust the map and refrain from contributing correct information, leading to ongoing errors and mistrust. The causal relationship in cartography is evident when data collection directly leads to map creation, which then facilitates user applications such as navigation. For example, gathering detailed topographic data results in a topographic map that hikers use for navigation. Without this data, the map would be useless for navigation. Reversion shows how outdated maps result from a lack of updates, causing navigation errors and further discouraging updates. If a city map is not regularly updated, users might encounter unexpected road changes, leading to navigation errors and a further decline in map accuracy due to reduced feedback and updates. Nonlinear relationships in cartography can be seen when new technology increases user engagement, leading to better map features. For instance, incorporating augmented reality, AR, in maps can significantly boost user interaction, resulting in enhanced map features tailored to user needs. Conversely, retrospective relationships illustrate how the lack of user feedback leads to outdated maps with missing features. If users do not provide feedback on map usability, cartographers might not update the map to reflect new developments, leading to obsolete maps with significant missing details, further deterring user engagement. Inclusive patterns in cartography involve user-generated content supporting community mapping efforts to create comprehensive maps. For example, platforms like OpenStreetMap rely on contributions from users worldwide to produce detailed, inclusive maps that benefit all. Exclusive patterns highlight the negative impact of lacking community involvement and updates, leading to incomplete maps. When a mapping project does not engage the community or fails to update its data, the resulting maps are often outdated and less useful, reflecting the absence of contributions and updates. Conjoined relationships in cartography emphasize that map standards ensure accurate data and clear visualization, reinforcing each other. For example, adhering to cartographic standards ensures that data is represented accurately and clearly, making maps more reliable and useful. Bottleneck patterns demonstrate how data inaccuracy and poor visualization lead to non-compliance with standards, perpetuating these issues. If a map's data is inaccurate and its visualization poor, it fails to meet cartographic standards, resulting in continued inaccuracy and poor usability. Harmonic relationships in cartography involve interactive maps with real-time data leading to user satisfaction. For instance, a live traffic map that provides real-time updates helps users avoid congested routes, increasing their satisfaction and encouraging further interaction. Dissonant relationships occur when user dissatisfaction leads to lack of interaction and outdated data. For example, if a traffic map provides outdated information, users will become dissatisfied, reduce their use of the map, and cease contributing updates, resulting in a perpetuating cycle of disuse and inaccuracy. Convergent relationships in cartography are seen when good map design enhances usability and functionality, with each aspect supporting the others. For example, a well-designed city map with intuitive symbols and clear layout makes navigation easier, enhancing both usability and functionality. Divergent relationships illustrate how poor usability and lack of functionality result in ineffective design. If a map is cluttered and hard to read, its usability and functionality suffer, making it ineffective for its intended purpose and deterring users. Combination in cartography involves balancing innovative features with traditional elements to offer user adaptability. For example, a map app that combines modern GPS technology with classic cartographic symbols provides a familiar yet advanced user experience. Division, on the other hand, shows how a lack of innovation coupled with over-reliance on tradition leads to poor adaptability. An outdated map that does not incorporate new technology or design trends may fail to meet modern user needs, reducing its effectiveness and adaptability. Association in cartography is seen when a strong user community combined with innovation enhances practical application. For example, a mapping project supported by an active user community and innovative features like crowdsourced data can produce highly practical and up-to-date maps. Disassociation occurs when a weak community and lack of innovation result in impractical applications. If a mapping platform does not engage users or innovate, the resulting maps are likely to be outdated and impractical for current needs. Integration in cartography involves combining data integration with consistent updates to enable comprehensive analysis. For instance, integrating various geographic data sources and regularly updating them ensures that maps provide accurate and comprehensive information for analysis. Disintegration shows how inconsistent updates lead to data fragmentation and incomplete analysis. If map data is not consistently updated, it becomes fragmented, reducing the accuracy and completeness of any analysis based on such maps. Our exploration of cartographic elements through the framework of affirmed and negated triads has provided a structured understanding of the intricate relationships that underpin effective mapmaking. By examining pairs of triads, we have highlighted how various elements in cartography, such as geographic features, map symbols, user interpretation, data accuracy, and community involvement, interact to influence the overall quality and usability of maps. By understanding these relationships, cartographers can better design maps that are accurate, reliable, and user-friendly, ultimately enhancing the value and impact of cartographic products in various applications. This structured framework not only helps in diagnosing and addressing current issues in mapmaking, but also guides future innovations to meet the evolving needs of users and technology.